Yeah.
Yeah. So this question seems like even I haven't tried this question. I just saw this. It's written like find the closest palindrome. Given an integer n, find the closest integer not included itself, which is a palindrome. The closest is defined as absolute minimum between two integers. Uh, I need to mute someone. So it seems like if input is 1, 2, 3, and the output should be 1, 2, 1. That's the closest uh, palindrome as closest is defined as the absolute difference minimized between two integer. So yeah, so I think what it says like we have given 1, 2, 3, and it's let's it be a string, and we need to find a palindrome which is closest to that number. So closest means it's difference between this and so 1 to 1 is a palindrome, and its difference from 1 to 3 to 1 to 1 is just 2. So which means like it's a closest palindrome uh, with 1 to 3. And it's given that this length would not exceed by 18. And if there is any tie, then return the smaller one as an answer. Like if we have something which is 1 to 1 as well as some other number, then whatever and the difference of both those numbers from the target is same, then we need to return the smallest one of that. Anybody has any approach for this? Anyone tried?
I tried this question.
Yes, yes.
I didn't code it, but I had an approach, a
Yeah,
bit
you
of
can
the.
share, like, we don't have any approach yet. It would be very helpful if you can share your approach.
Yeah. Like I could make it clear if I share my screen.
Yeah, yeah,
Probably.
sure.
Yeah. Just. That's question number 5. Yeah, see, here I saw a lot. I tried here a lot of examples, and what I found was, there are if there are a number like any number, take it like 1, 2, 3, 4, 5. So what we need to do is we need to convert it into a palindrome, the nearest one. In
Hmm.
most of the cases, what I saw was the palindrome would be like we need to find the middle element. In this case, like this is odd, so we need to find the middle element, and we need to replicate the left half with the right half because that will give the lowest absolute difference. That will give the minimized absolute difference. So in this case, I guess it will be 1, 2, 3, 2, 1. And in most of the cases, consider an arbitrary case like, for some 6 digits. So here as well, I think the palindrome number that we want is in this case we have 6 digits. So if we replicate the first half, the first 3 digits with the last 3 digits, so we'll probably get our palindrome number with the minimized absolute difference.
But I also thought the same, but I don't think that's a foolproof thing because a number
That's
might
not
itself start
applicable
with like
for.
let's say in case of 1, 2, 3, 4, 5, it
And
can.
yeah, one more question I had, like if like the palindrome number should be greater than the input number, or it should be lesser than the input number.
It doesn't matter as long as the
It's
palindrome the difference
yeah.
between the palindrome number and the given number is minimum.
So
Oh, okay, cool.
If you have two cases, one is larger than the palindrome number and one is smaller. So we have to pick the smaller one in that case.
So, so why you did like 836,638, but it's not that smaller from, it's not the smallest number. Yeah.
Yeah, it's not the smallest number, but like when we have when we want the absolute difference minimized, in that case, if we'll be taking the, ones place, tens place, hundreds place, starting from this, the rightmost place, if we'll be changing the number there, then we'll get the minimized difference only, minimized absolute difference only between the numbers.
I think
You
What
Puneet
know,
if
is
the
saying
integer
you,
value is like 10,000 and all? Like if 10,000.
yeah, this case creates a bit of problem. Like if I have given 10,000, so there are two possible cases. One is 9999, and the other one is 10,001. So here we need to choose this number, but going by my approach, we'll replicate and get this number.
yeah, that would make, and similarly for if you have any number like 3,000 or something like
Yeah,
that.
any number of such sort. And there's a problem with one more case as well. If I have been already given with a palindrome number, like if I have been given this, so I can't return the same number. I need to go to some other palindrome number, and then I'll, like if you could see in this case as well, the test case that I have tried, just for the sake. So it is a palindrome number itself, but I can't return but I can't return the same number. I need to find some other palindrome number which is nearest to it. So, but what I think here, I'm not pretty much sure, but in most of the cases, what I think is we are taking the middle number and then either adding or subtracting one to the middle number, In case we have even number of digits, so we are adding or subtracting both the middle digits by one, and similarly, I don't know specifically, but it's, yeah, quite like that.
11 is also one special case. If you have given
Uh,
11, then the
yeah,
closest palindrome is 9 to it.
yeah.
But 11 is itself a palindrome.
Yeah. So
Yeah,
based on
we
this
can't
question,
return in every.
yeah, but you have to exclude the parent whatever number is given.
given, yeah.
Yeah, and what I think when we have palindrome, like if we have this, so what we can do is, let's suppose we take just one half. Let's suppose we take 10 only for the consideration, and now we subtract one from this number. Okay, so we get 9, and then we replicate it to the other half as well. We get 99. I might not be clear right now to you guys, but if I take one more example, like I take 1 2 3 3 2 1. Okay, if this is the number, I have got palindrome number as the input. Am I audible to you guys?
Yeah,
Yes.
yeah, yeah.
Yes,
Yeah.
have you coded it?
No, I didn't. I just checked all the test cases on how I could do it, and this is the only thing that I got. I
I
didn't
think the
code it.
test case is the key part here, because
Yeah.
I'm
So did
sure
you,
there might be.
so you also, whatever the test cases you run, is it your approach is working in all the cases or there is some other?
Yeah.
Okay.
So, like if I have been given with this palindrome number, so I just bisect one of its half. I take 123 for consideration right now,
Mhm.
and then I could add one or subtract one. Like I'll have 1 2 4 and 1 2 2. Okay,
Mhm.
and then I'll replicate the same. I'll take the mirror image and I'll create two palindrome numbers using this. It's like 1 2 4 2 1, and oh sorry, 1 2 4 4 2 1, and 1 2 2 2 2 1. So these will be the two closest palindrome numbers.
Candidates.
Sorry.
Yeah, I meant to say we basically need to check the difference of these two.
Yeah, and then we need to check the difference and whichever is the smallest. We could check it once at 1 2 3 3 2 1. This helps.
12397. What is there on the chat?
So Puneet has given the question about 12397. So I think its answer should be 12321.
Yeah, that's pretty straightforward. It's 1 2 3 2 1.
Yeah.
So you see here, I've got the expected result is 1 2 2 2 2 1. It might be because the difference between 1 2 2 2 2 1 and this number is smaller than this and this.
Yash, can you explain the concept again? What you were explaining right now regarding 124 and 122?
Okay, yeah. Yeah. So you see, we take any number as the test case, any palindrome number. If okay, if I take like 963369, I have this as the input. Okay.
Okay.
So first of all, I take into consideration the first half of the number. So the first half here is 963 only.
Okay.
So
You move it.
what?
Yeah.
Yeah. What I can do here is I can either add one to it or subtract one from it. So I could do it like 964 or 962. Okay.
Okay.
And then what we just need to do is we need to create a mirror image of the same. It's like 96469 or 9622269, and we need to choose one among those among these, which one is smaller. But I think in most of the cases the one that is smaller would have less difference going
And
by.
that is 962, right? That will be the less difference.
Yeah, I think
So,
so. That just
so
strike
in
it.
that case, then it will be taking 96269.
Yeah, in most of the, and I think in all the cases, maybe we need to take the smaller number only. We need to just subtract it by one. We don't
So
even need.
how will like this is, and I think a human side approach. How do you tell the computer like, yeah, 96, like 960, or like, if you mirror it with 369, it becomes 360. I'm asking in that case, like 962, it's okay. When you subtract with 963, it becomes 962. But after that, the 269 process, I'm asking.
That's actually, we would have been given a string here. So that's quite an easy task to do. Hello.
Well, okay.
We have got a string here, so I don't think that will be a problem.
So that, yeah, you just have to take it reverse from half and convert.
Yeah, reverse and join.
Yes, I have one doubt. Can you take an example of a even number, basically the even count, not the odd,
The odd count, I guess.
Even like
which
300,
doesn't have the middle element?
3000.
This.
Yeah, let's take.
Yeah, let's do with that.
Okay. So in this case, see the earlier cases were what I told here. This was regarding when I have the palindrome number given. I need to check it first if it's a palindrome or not.
Yeah.
If that is a palindrome number, then this approach will follow the one which I told here.
Right.
And in this case, what I think is like we'll have 3003. There would be two possibilities. One is going by this approach that I told, it will work in most of the questions. One of those number would be 3003. We'll take half and replicate it.
Mm-hmm.
Hello.
Yeah, yeah. Yeah, we are there.
Okay, and the other number, I couldn't really think of it.
So
I
you
think
were saying something like subtraction and then coming up with like if 30 is subtracting with like 29, like 29 and then
Yeah,
No,
like
that's the
yeah,
case of
29.
that
Yeah. Even I was about to say that.
I think that thing is more, that will work a bit better when I have something like this, 1001, because we'll have two quite close numbers. One is 99, it's 999 here, and 1001. So either we need to explicitly tell the computer to handle such cases, or uh,
if the
I don't
difference is
know.
equal, then we need to take the smaller one like
Yeah.
that.
So in this case, we have the absolute difference, one for 999 as well and for 1001 as well. So in this case, we need to take the smaller one, but I'm not sure. How do we need to tell the environments explicitly for this case to handle such cases where we'll encounter 1,000, 10,000 or so?
Will it work for odd numbers or digits?
Uh, for the palindrome number with odd digits?
No, I guess he's asking normal number.
Yeah, it will work. We have taken two examples here. This has 5 digits, and it gives me, after replicating the first half, it gives me 1, 2, 3, 2, 1. We
Is
just
it
need to,
1, 2, 3,
Same
4?
for 9,999.
just a minute.
Actually, it's given that you'll not exceed 18 digits.
Yeah.
Yeah.
Yeah. Are you talking about this?
Yeah, Puneet asked for this.
Yeah. In this case, what I told here, I think this will help. What I told over, we could bisect it. We could divide it, so we'll get 99. And then what we could do is we could add one and subtract one. So adding one will give me 100, and subtracting one will give me 98. And then I could take a mirror image of these, so it will give me this, and 98 would give me 9889. And so I think
I
this
think
will help me in this case.
yeah, 9889 is more closer. Yeah, this is work. Actually, Puneet is saying the answer of this is 100, like 10001. Yeah, answer is
Yeah,
10001.
basically 10,001.
This is
Yeah,
more closer.
yeah, this is more closer. Correct. So how this would be solved?
Um,
Like remove 10 from this, the answer should be like that.
10, yeah, from that answer.
okay. Could we just do it like, let's try it first for 3 nines? Okay, for 999.
Okay.
We have not taken any number with odd number of digits. Yet. So for this case, what we need to specifically do is, if we fetch the middle element, it's 9 only. Okay, and
Yeah.
then we add, if we add one, no, it's going to be a bit problem here. I'm sorry, but I couldn't specifically handle this case.
Yeah, there is one more like 22. If input is 22.
If the input is 22.
Yeah.
So we'll have 11 and 33. In this case, we could
You're adding
the half.
Take half minus
and
1.
decreasing.
And then
Okay, yeah, then it
one,
will work. Yeah, got
and
it.
then
Yeah, so
11.
only 1,000 case is something which we need to take care separately.
Yeah, the 1,000
Something like
ones
that.
and the
Yeah.
9,999.
Yeah, I mean,
And
whenever it's multiple of 10. That
And
seems.
also, if here, like I took 963369, if I take 96369, then I think it's quite straightforward. What we could do is we could just change this 3 to 2 or 4.
yeah.
Yeah.
But I
Yeah,
think
it's
it's very hard to code. Like you
Yeah.
don't know
It seems we need to write something special for these 100, even if given number is 100, 1,000, 10,000, or after our approach, it reaches to those things, right? That then only we are able to.
But from thinking perspective, it's very nice. Like, I mean, as a human, we can devise this, like, it's working. But I'm sure there are some cases which we are not aware with.
Yeah, but I think these two will be those specific cases. I've not checked the solution tab yet. Should we check the solution once? If we get something.
When everybody says yes, we can check.
Yeah.
Or someone wants to try out.
Hey guys, like if you give me 2 minutes, I will try to explain in a hopefully better way. But I'm asking for 2 minutes because I will be in a place where I can actually talk. So go on.
Sure, Roger. It's fine. Actually, we are discussing some cases only. Then Puneet is asking for number 8.
For number
8.
8.
That would be
For a single digit number, we could return 7 only. We could return
Always
-1.
-1, yeah.
Yeah.
which is 77 or
No, 7.
No. Single digits.
okay, 7 or 9.
We'll return 7 for all the time because we need to return this number 1.
Okay, yeah, 7 is a got 7 is also very much. So did we solve this particular problem? Sorry, I haven't touched with that. 9999, like our answer should be 1001. That's one of the problem we need to handle that. Correct?
Yeah. The answer must be this.
I think Roger will explain more. The answer is 100.
10,001.
Yeah, 10,001. Correct.
Answer would be this, right? This is the wrong one.
Yeah, I think when you are doing mirror image 10, I think somehow we need to ignore.
But if we know if these are the only cases, then we can probably handle them. But not sure.
Okay, I'm on. Can you hear me? Hopefully
Yes.
Yes.
there's
Yeah,
not
Roger.
too much noise.
Yeah. Do you want to share your screen?
Sorry guys, I'm walking.
Oh,
So
okay.
yeah. So we will talk about couple of things. Like you have a number of n digits. Do you agree that our palindrome could be of n plus 1 or n minus 1 digit? Is
Yeah.
that right?
Yeah.
So let's get rid of the special cases. Whenever I'm moving from n digit to n plus 1 digit, I would like to go to the smallest n plus 1 digit.
Mm-hmm.
True? For the so that delta will be less. So,
True.
right? So what could be the if I have some 97 and I'm looking for the smallest 3-digit number, which is a palindrome, it will be 101.
Yeah.
And that is that is static. Like without thinking, I can tell what is the smallest 3-digit number, 4-digit number, 5-digit number. Fair?
It will be 99, I guess.
No, like 3-digit smallest palindrome number is 101.
Yeah. 3-digit would be 101.
And 4-digit will be 1001. You will have 11 on the end and then just zeros, right?
Yeah.
Yes.
Okay. Now, if I am coming to n minus 1 case, like when I had a n digit number, and I am going to n minus 1 digit palindrome case, then I will like to choose the biggest number so that my delta will be different, least. Is that fair? Because
Sorry, can you explain this again?
yeah, so suppose you have any 3-digit number,
Mm-hmm.
and my candidate is a number which is of 2 digits, I would always choose 99, because anything smaller than 99 will be far from that number, because that number is 3 digits, and when you will try to subtract any value of 2 digits, it will be more than what I will get from subtracting just 99.
Okay. You are taking the upper cases means.
Yeah, I am just choosing those first those two cases. Either we go up or we go down, and then we will focus on the core crux where you guys were talking about.
Yeah.
So
Okay.
if so, these two cases are pretty clear, right?
Yes.
Yeah, n plus
Okay.
1 and n minus 1 is clear.
Clear. So we have these two candidates. We will evaluate them, especially, right? Now, what about the case where we have n-digit number, and my solution is also going to be n-digit number? So
Yeah.
somebody already thought about, like, mirroring the stuff, which
Yes.
makes, yeah, it
Yeah.
totally makes sense because palindrome, it's the nature of palindrome to get mirrored. So we could have thought about mirroring the right part. Right means the like least significant bits towards left versus less significant bit towards right. But we chose to mirror left significant bit because that will make our
Smallest. Yeah.
delta smaller. So
Right.
that's a very nice thinking that way. Now I will explain, like, take any number, like take 2, 3, 4, 5, 6, for example. Because this is where we have to do something.
Okay.
So can somebody write 2, 3, 4, 5, 6? I can't see that much, but it's still, like, I can see your writing.
Can you write 2, 3, 4, 5, 6? Yes.
Yeah.
Yes.
And as I guess Yes was explaining, like when we are trying to mirror, we will mirror it to 2, 3, 4, 3, 2. That's right?
Yes.
Yes.
Okay. So that way your delta will be like 56 minus 32, right?
Yes.
Which is a very good solution. So it's a very valid candidate. Now just think, like, if I am changing my number from 2, 3, 4, 5, 6, and I will say why I am changing, but like, just think for now. Like 2, 3, 4, 5, 6, I want 2, 3, 4, 9, 9, for example.
2, 3,
499.
23499.
Now try to apply the exact same thing which Yes was trying to, like, not Yes, like, let's try the same thing which we just did, like 2, 3, 4, 3, 2. Okay.
Will be
Now
2, 3, 4, 3, 2. Yeah.
And so what happened now, if you see the delta is 99 minus 32, right?
Yes.
Yeah.
Okay. It's more than 50 for sure, right? More
Which is
than 50.
67, yeah.
Yeah.
Yeah, that's 67.
Now had we,
50.
Sorry.
yeah, exact is not like, it's fine.
No,
Good
it's
enough.
67.
67. It's 67.
67, yeah.
Okay. Now suppose if I would have changed, instead of 2, 3, 4, I would say 2, 3, 3, 3, 2. Like your new candidate, if it becomes 2, 3, 3. So no, same example, your number is same, like 2, 3, 4, 9, 9. But now you are
Okay.
saying that
23499 and it goes to
2, 3, 3, 3, 2.
2332. Is that okay?
Yeah. What is your delta?
No, there are
It's
two
more than
things.
100, I think.
332.
It's quite a big number, right?
Yes.
Yeah.
And what about if I would compare it with 2, 3, 5, 3, 2?
That'll be smaller.
2353.
2, 3, 5, 3, 2. We don't want exact subtraction, so don't worry. Like, we'll just get something out of it.
It's 33. It's less than 67.
Exactly. So why that happened? Because you had a number at 100 place. Some number is like at a 67 distance from it. So if you go to the other end, you will get closer to the number, because it's always 100 difference between 400 and 500 and 600, right?
Mm-hmm.
So that's the point that we decided, hey, let me compare this with 23532, because maybe I will get closer to the number rather than just comparing with 2 3 4 3 2. And so you know the significance of going up here, like 2 3 5 3 2 is a good candidate because 2 3 it is better than 2 3 4 3 2. Is that clear? Or you take your time. If it is not clear, we can spend more time. You will
Uh,
find.
yeah, I got your approach because it's making like taking in other case, it's making us smaller rather than just going for uh,
So
that
yeah,
particular.
one question, Roger. So 100 is key here because the thing which we are changing was 2-digit, right? The mirror image was 2-digit. So
Exactly. If it
100 is
was
the key.
1000, exactly.
Yeah. If it is
If it,
3-digit, then 1000 is our key. That
totally.
got
Yeah.
it. Got it. Yeah.
So,
Yeah.
so
Nice
that's the
explanation.
intuition.
Yeah.
So now, just to finish that, like to choose a number, call it 99. Start with 99, and then whatever was our previous number, it doesn't matter. 456 maybe,
Okay.
or yeah, maybe. Or maybe make it 432. Like, that should be okay. So again, if you go with the same approach, now when you will mirror it, like without changing the digit, it will be 99499 maybe,
Yeah.
almost a difference of 67 here.
Yeah.
Cool.
Okay, and if you go up to 99599,
432 to 99
5.
yeah,
599.
599, will it be even more far, right?
Yeah.
But if you go to 99399,
432 to 99399.
yeah, so the delta will be very close, actually 33.
Yeah.
Yeah.
33.
All I am doing is, like on that number line, I am trying to go left or right to get as close as possible to the number. I mean, that's the core intuition part of the solution, right?
So, Roger, how do I decide whether I move down or up, or should I compare every time?
No. So what we are doing, like you don't know that what number could be. So you are
Yeah.
deciding all the possibilities your number could be in. So we had two special cases. When we go, like when the number itself changes, then the solution will be 10001. If number goes down, then it will be 9999, something like that. And the middle case where palindrome will be of the same length, that can be handled by this particular approach. Three cases for this middle case basically. You have total 5 cases. So what you will do, you will generate 5 candidates for any number, and you will just select whatever is best for you, and that's it actually.
Yeah, Roger, one question.
Sure.
Yeah, this approach that you are telling about, I think this is required for when we will have odd number of digits.
It will work for even also.
Do we need it for even?
No, what I'm
Do-
trying to say that don't go case by case. I'm saying just you make 5 cases. Now inside this 5 case, everything is already covered. It will be easier to code if you directly generalize this thing.
Got it.
Yeah, got it.
Yeah, so you don't handle each case.
But
Like,
I still have one doubt.
sure.
I think we discussed 4 cases. What is the fifth one?
First one was 1001. Second was 99 case, right? When you want to go
Yeah.
down a
So
bit.
n plus 1 and minus 1. Yeah, there are 2.
Yeah, and then third case was the base case, which yes was in the beginning mentioning that you just mirror the left part to the right part and you get the best solution. Most
Oh,
likely,
got it. So we are considering that also as a candidate.
yeah, because it was solving a lot of cases
Yeah.
already.
Solving the problem.
And these two extra cases when you flip the middle element. because now you are on a number line. You want to grow closer into the other towards the other end.
Yeah. One time increase, one time decrease.
Yeah, I will share the code, and I will say it's not from my direct approach. I had solved it a year back, and it was in my saved code, so I will share it. So now you know the idea. So now it will totally make sense, I believe.
Could you please tell the fifth approach the four I have mentioned?
I think the fourth one is the actually two cases. Flick middle element. One is you have to increase, one time you have to decrease.
Okay.
That's why we started with that 99 number to begin with, because I want to go to the other end of the line. That's why I chose, because when you will mirror anything which is ending with 99, you are very close to the next bigger digit, right?
Yeah.
So that's why uh, that case works. Any question?
Puneet is saying he shared the code on chat.
Okay, great. If
Yeah.
that is the same approach, it should be. Oh, my code is there on the. Okay, good. I will share this approach maybe by evening today.
Yeah, sure.
All right.
Okay, thank you so much.
Thank you.
Thanks, Roger.
Thank
Yeah.
Thank
you.
you.
Thanks for like that was the case we haven't discussed about, and that's the that helps a lot. So anybody else, anything they want to discuss and end with any approach? If it is
No,
not,
I think we are just on time.
yeah, we are on